In this video we'll be talking about sonar. Now sonar is the use of sound to see through water. This technique has been used by whales and dolphins for millions of years. We've now taken it and made a form of technology which allows us to do the same. In the image before you we have one variation of how sonar can be used. So you have a ship which has a transmitter and a receiver on it. Now the way it works is that we send out a pulse or a ping. As you can see, it will go down in a single direction. Now the speed of sound is constant, so it stays the same, it doesn't change. So we can actually time how long it takes to go down to the bottom, bounce off an object, and head back up to the receiver. So once we have the time, we divide it by 2, since there's a signal going down and a signal going up, and we'll find out what the depth to the bottom of the sea is. Now that's okay with a situation where the seafloor is nice and flat, but what about if we have an object? So we'll create an object. Okay, here we have a nice rock, and we're going to send a sonar signal down towards it. So the transmitter will send out its ping. Make it nice and big so it's nice and clear, and will eventually hit the object. Now when it hits the object, the areas which are closest to the signal will bounce off first, and those which are further in will go last, and those which are furthest away will obviously take the longest before they start bouncing back. And the end result is we'll get a nice reflection which looks like the rock. And that's the signal that will bounce back. So we get a bent or a disturbed signal back, and this allows us to take a 3D image of the object on the ground. Now we don't just send a single small pulse down, we actually sweep across a large area. So as you can see with this ship, it actually does a nice large space or arc as it travels back and forth. And this means that it can actually search quite a large area as it's travelling back and forth. So you can see here it's an artificially coloured chart where the hotter colours are shallowest, as up here. And all of a sudden we have a cliff going down, and as the cliff drops you can see it going into the cooler colours, and it goes down deeper and deeper. And this ship will travel back and forth through the ocean, mapping it out. Now, oops, went too far. Here is a good example of such an area. So this has been mapped out and then artificially coloured to make it easier to see. You can see over here there's a really nice shallow area, so the hotter colours again show the shallowest area, and as it goes to the cooler colours, for the oranges, the yellows, then into greens, and then finally the blues and violets, it becomes deeper and deeper. And you can see features such as cliffs along here and here, and there's even a small readout which is poking out there. And over here we have a key which shows us what depth each colour represents. Now we don't only use it for these general things, we can also map out things such as this rift. Now this is exactly what we were discussing when we talked about the mountain range in the Atlantic where the cable first came across. So when they were laying the cable back in the 1800s, they actually came along and they reached this, and they had to go up and over it, and then it sort of dipped into here a little bit and then came up and back down it. And this is how they discovered, so they actually were measuring the depth of the ocean as they travelled, and that's how they discovered this mountain range. And little did they know that this range actually travelled all the way from the North Pole to the South Pole. Now we actually still have cables running across this ridge, and every now and again as we have movement of the tectonic plates, it will snap in these areas and have to be repaired. Now that's the natural features which we have, but mankind's been littering the ocean for many years, especially in the last 100 years as we've had lots of wars. And here are a few things which have been discovered since. So as they've mapped around, one of the most famous ones is this one here. For those that you don't know, this is the Titanic. And it was done through finding out first of all what its course was, and then finding out approximately where it would be, and then they use side scanning sonar to go back and forth, and they found the Titanic. And what we have here is the actual ship. Now what I'll show you first is how it looks like from the scanner. So you can see the lines traveling up and down as the sonar traveled back and forth, and over here we have the back of the ship, and over here we have the front of the ship, and they're actually a couple of kilometers apart because it broke up near the surface and then floated away down as it headed down to the bottom. And what we have here is, if you look really carefully, here we have the bow of the ship, and you can see the bridge through here, and then 1, 2, and a little bit of the last funnel towards the back here, and around here is where the ship broke down. So it's a really clear image. Other images which we have, this one here is the Britannic, which is a sister ship to the Titanic. You had the Britannic, the Titanic, and the Olympic. This one here was used as a ship during the war as well, and you can see through here a hole where it was torpedoed and it sank in fairly shallow water. And this is a scanning radar of this. This ship here, the HMS Royal Oak, is a battleship from the Second World War. It has the dubious honour of being the very first battleship which was sunk during the Second World War, and this is a scanning image which they've got of it. And up here, this is actually a German bomber which was sunk in the English Channel during the Battle of Britain, and it was discovered again through side scanning radar. There are hundreds and hundreds of wrecks in the English Channel, and this is one of them that was picked up. This particular plane here has actually been raised since, and is now sitting in one of the maritime museums in England. So that is a quick explanation of how sonar works. For the next video we'll be talking about seafloor spreading and the development of tectonic plate theory.